Hello everyone, welcome to this session. My name is Francis Kihiko, and today I would like us to look at introduction to object-oriented programming. What is object-oriented programming? When it comes to software development, we have various ways of designing and developing a software. One of them is structured programming, and another one is object-oriented programming. And today I would like us to look at object-oriented programming. What is object-oriented programming? It's a programming paradigm that revolutionized software development by introducing powerful concepts and methodologies. Object-oriented programming focuses on organizing code into reusable structure called objects, which represent real-world entities or concepts. By leveraging the principle of encapsulation, inheritance, polymorphism, and abstraction, OOP provides a module and flexible approach to software design and implementation. Programming, there is so many other advantages which we will not look into all of them at this time, but during your own time you can take time and go through and look for more advantage object-oriented programming over structured programming. The other part that I would like us to look at today is a fundamental concept of object-oriented programming. And one of them is called encapsulation. This is bundling of data and methods with a class, providing data hiding and abstraction. Another concept that we are going to look is inheritance. This is the ability of a class to inherit properties and behavior from other classes, promoting code reuse and hierarchical relationships. Another term that we are going to look at is polymorphism. Polymorphism is an object of different classes. Objects of different classes can be treated as objects of common superclass, enabling dynamic and flexible behavior. The other one is abstraction, which focuses on defining essential characteristics and hiding unnecessary implementation detail. So those are four concepts that of object-oriented programming that you're going to look at it later during this session. So I would like us to look another part in a part of fundamental part of object-oriented programming, which is classes and objects. What is a class? You see, a class is a blueprint or template that defines the structure and behavior of an object. An object are instances of classes that represent specific entities or concepts. You see, when it comes to software development, to object-oriented programming, let us assume we want to develop a software that keep records for all animals that we have in the world. We have cows, we have cats, we have buffaloes. What else? Name them, all of them. We have goat and what else? So in this development, we're going to have a class called animal. Animal is a container, it's like a container that holds all other objects. And animal, and cow is an object. An object is an instance of a class. It is contained inside a class. We have said that a class is like a container. In this case, is an animal. Each animal has got its own. Okay, an animal, they have attributes and properties that they share, but it boils down to a point where each animal has got its specific characteristics and properties. And we're going to look at that as we dive deeper into this. Let's continue. Look some of these terms called encapsulation. Encapsulation combines data and method with a class, promoting data hiding and abstraction. Data hiding ensures that the internal state of an object is not directly accessible from outside the class, maintaining data integrity. Abstraction allows classes to expose only relevant information and behavior, hiding unnecessary implementation. Inheritance. When it comes to inheritance, it allows the creation of classes that inherit properties and behavior from a parent class. In our case, we are developing a software that keep records for all animals. We have a superclass called animal that contain all animals. We have another class. We can have another class that describe about a cow. A cow is another class from a superclass called animal. So this cow can inherit property of a superclass called animal. An animal have behavior like it can walk, it can eat. Those are attributes that all animals can share and that a superclass have. So in this case, cow can inherit property of a superclass called animal. So, and that is what inheritance is. Another concept is polymorphism. Polymorphism enable objects of different classes to be treated as objects of a common superclass. It allows objects to take on multiple forms and respond to the same message differently. Polymorphism support methods of overriding, whereas superclass provide a different implementation of a method and method overriding, where multiple methods with the same name but different parameters exist. Another is abstraction. Abstraction focuses on defining the essential characteristic of object while hiding. You see, for example, you have a car, you are the driver, you have the key, so your work is just to go and put the key on and switch on, but you don't have necessarily to know what happens once you put the key on. You don't have to know what happens at the background. That is abstraction. Your work, or the only thing that you need to know is that you have to put the key and put on. Then the rest you don't have to know. That is abstraction, hiding the unnecessary details and only revealing the necessary details. That is what abstraction means when it comes to software development. Like, for example, you have the school system, the school portal. The only part, once you log in, the first part of logging in, you are required to enter your details, your username and your password. It verifies. You don't have to know the process that it does before it can verify, it can allow you to access the system. That is called abstraction. The only thing that you need to know that you have to feed your password and username. Then how it takes your details, you don't have to know. That is abstraction.